Let us now discuss about the mechanism of mixing and the theory of mixing. Mechanism of solid mixing. The principal mechanism in solid mixing are the following. 1. Convective mixing or macro mixing. 2. Shear mixing. 3. Diffusive mixing or micro mixing. Let's see what is convective mixing or macro mixing. Convective mixing is achieved by the inversion of the powder bed using blades or paddles or screw element. A large mass of material moves from one part to another in a convective mixing or macro mixing. Due to the movement of material within the system, the mixture, it is called as convective mixing. Let us see what is shear mixing. The force of attraction are broken down by shear forces so that each particle moves on its own between regions of different composition and parallel to their surfaces. So here the force of attraction between the particles has been broken by the shear force, hence it is called as a shear mixing. The third type is diffusive mixing or macro mixing. During this mixing mechanism, the mixing occurs by diffusion process by random movement of particles within a powder bed and cause them to change their relative positions. Diffusive mixing occurs at the interface of dissimilar regions. Flow characteristics of powders largely determine the ease with which the primary particles can be mixed. Let us move into the mechanism of liquid mixing. The mechanism of liquid mixing can be studied under four classes. 1. Bulk transport. 2. Turbulent mixing. 3. Laminar mixing. 4. Molecular mixing. Bulk transport. Bulk transport is defined as the movement of large portion of a material from one location to another location in a given system. For this purpose, mixing devices such as rotating blades and paddles are used, which moves the material in different directions. Turbulent mixing. Turbulent mixing is defined as a mixing due to turbulent flow which results in a random fluctuation of the fluid velocity and at any given point within the system. However, the liquid moves in one direction depending on the dominant component. Turbulent flow is a highly effective mechanism for mixing, and this is one of the major mechanisms we use in liquid mixing. Laminar mixing. In a laminar mixing, the mixing of two dissimilar liquids through laminar flow, that is, the applied shear stretches the interface between them. In this mechanism, layers fold back upon themselves. This is suitable for liquids which require moderate mixing. Molecular diffusion. Molecular diffusion is the mixing at molecular level in which the molecules diffuse due to thermal motion. Molecular diffusion is explained by Fick's law, which depends on the concentration gradient at different regions. The concentration gradient decreases with time and it reaches zero when mixing is completed, that is, in an equilibrium condition. Mechanism of Semi-solid mixing. Let us see how semi-solids can be mixed. While mixing such dosage forms, that is semi-solids, the material must be brought to the agitator, or the agitator must move the material throughout the mixer. The mixing action includes combination of low-speed shear, smearing, wiping, folding, stretching, and compressing. The force required for efficient mixing are high, and consumption of power is also high. Let us move on to the theory of solid mixing. In the solid-solid mixing operation, 4 steps are involved. Let us see which are the steps. The first step is expansion of the bed of solids, followed by application of 3-dimensional shear forces to the powder bed. Then it makes long enough to permit true randomization of the particles in order to achieve uniformity. Fourth, maintaining the randomization so that no segregation happens after mixing. When dry materials are loaded into a mixer, they form a static bed. This bed expands sufficiently when mixing is initiated. Therefore, there should be more void space in the mixer after it is loaded with the ingredients. In order to compensate the expansion of the material, there should be sufficient free space. The shear force produces movement of particles. This is accompanied by expansion of powder bed. This turbulent movement of the particles achieve randomization. Mixing is expected to produce a random distribution of particles, which is referred as degree of mixing or degree of homogeneity. It is expressed by an equation m is equal to a into 1 minus e raised to minus kt. M is the degree of mixing and is connected to parameters such as time, area, and k, which are constant terms. Thank you.